Okay, next idea here with this is pop in the tubes, and it is in such bad shape underneath. We could, for fun, use a power supply in the shop here and raise the B plus on the radio, with the tubes actually not operating, with no heater, not plugged in, radio not plugged in. Just raise the B plus and see how much, see what happens. That might be fun to do. Yeah. Okay, here's a look at the schematic and bits and pieces, I guess, out of the service manual. There's a couple of other models of this radio cabinet anyway, C601 and a C602, and I've got the C600 version of this radio. Let's see, it's been typed in. Let's just expand this a little bit, get a better look at it. Okay. So first, you see the output is definitely a 35 L6, not a 50. And if we look at the string here, is there a resistor in here that could be removed? I don't see one. So how you can put a 50 in here and expect this radio to work normally, I'm not so sure. That's really a good idea. I think it's a bad idea, but it is what it is right now. So pretty straightforward radio. 12SK7. Now I pulled a 12, you know, I thought I saw that. I pulled the 12SJ7 out of this position, which seemed to be working quite well, but that goes to what I was saying about they're swappable. I guess they really are. For now, we've got a different tube in this socket from what the schematic calls for. Just quickly looking to see if there's anything unusual. There's a capacitor going back between the transformers. Wait a minute, that's not a transformer. This is the IF transformer in the can. Same thing here. This is how they're connecting the output from the RF tube to the mixer tube here using a transformer. And what a complicated affair that looks to be. Okay. Oscillator. So the oscillator primary coil, if I can call this a primary, is in the cathode. That's a typical way of introducing the local oscillator into the introducing the feed, or getting the feedback necessary to make the oscillator operate. There's the little tickler coil, if you like, sending a little bit of signal to the first grid. So a local oscillator on grid 1, signal coming in on grid 3, all quite normal. Come along. This is the IF amplifier. It has a cathode resistor bypass with a small capacitor here. Wait a minute, no, what is that? Pin 1. Pin 1. So this is not, no, it's not at all what I just said. This is a, the tube shells. The metal tubes are being grounded back, the shell on them, to the B minus line through this arrangement. 330K, yeah. So this is typically a technique you use to attach the chassis to the B minus, and I bet you we'll find that in here somewhere. The same technique has been used to connect to these metal shells. Yeah, metal shell here, and there's one here, pin 1. So this one, they show it connected to the chassis. I think that's what that means. Chassis. So here's another example. See, 330K, 0.08, does that say? 0.08? Must be a 5. 0.05, 0.08, I don't know what that's saying, but that's the same technique. So in this radio, there's a B minus wire. The chassis is not connected directly to the plug. It's connected indirectly through these. And what are these here for? If you just let the chassis float around in there, it's a wee bit dangerous in itself, in case something should short against it, but that's not really what this is for. If you leave the chassis floating around in there, it's a great big chunk of metal. It's going to pick up signals from the radio, from the air, from your local CB operator, and they're all going to be floating around in the chassis right next to all these coils and all this other stuff. And for sure, it's not going to help. So you want to connect the chassis to the B minus to drain that stuff out. You're draining it out with this capacitor, and at the same time, you're maintaining enough impedance and resistance in here that if you should touch the chassis and the plug is the wrong way and all this other stuff, you won't get a shock. You won't be able to draw enough current through here. So it's kind of important stuff. So that's what's going on here. And these things are all dealt with in various ways, like the shells on these tubes, the front end, the grounding of the capacitor, and the antenna arrangement. All these things are dealt with differently in different radios. What's this down here? Some interesting notes. Note, C26 was used in some series due to variations in L3. It was added to give a uniform gain across the band and to prevent a condition of loss of sensitivity at the high end of the band. If it is added where not required, it may be found that C3 will not have a low enough minimum capacity to peak the secondary of L3. Well, we'll investigate that. We'll revisit this when the time comes. That's very interesting what they're saying there. Lots of insight into what's going on in the radio, especially this statement. It was used in some series due to variations in L3. So I think what they're saying is when they manufactured this coil, it wasn't manufactured to tighten the tolerances, that they could get away with one design. Something like that was going on. It's interesting. L3 side view, L2 end view. Good show. They've marked the different connections here. That might be helpful in the end. And what's going on with the speaker? So speaker, we see there's no connection back to the chassis and no connection of the electrical part, no connection back into the radio, no feedback from here going back in the radio. The whole speaker is just isolated, but they have connected the shell to one of the lines here. I wonder why. Again, you know, there's a basic, it wouldn't make sense here. I was going to say there's a basic rule in electricity about not having any unconnected metal around, and a safety rule. Maybe not in radios here, but if you think about your house, or the place where it was really important was inside a power station. You're walking down the stairs and there's a big metal handrail. Believe it or not, there'll be a ground wire coming up to that metal handrail. Every piece of metal in the station is grounded back to the neutral. That's so that piece of metal can never be made live. If you try to make it live, it'll be a short circuit because of that connection back to the neutral, and boom. Yeah, boom. Boom is right. So I don't know why they did that. Some noise factor or something, I don't know. You wonder how can they make this connection onto the frame of the speaker and not have the frame of the speaker bolted solidly onto the radio? We're going to look in, because it's up in the cabinet. That answers that question. Okay, now look at the power supply here itself. Of course, there's no transformer. So an 18 ohm resistor here in the plate circuit. And where's the filter capacitors? Here's one. Here's the other one. I kind of like it when they show these not right up in the circuitry, but have kind of like a separate diagram of the power supply. It's a little harder to look at, probably more efficient for the draftsman here. So let's follow the negative wire here. Oh, is that a connection? I don't think so. It'd be just pretty good dots on the connections. I don't think that's a connection. But this would normally be between the... okay, I'm not going to study this at length right now, but there's something here to be sorted out. Just because of the way the diagram's laid out, it's not clear in my head how that works. Okay, let's go up here and we'll look at the output of the detector. Using well, that's interesting. What have they done here? So they've got the two plates doing something, but they're not doing the same thing. A great big 2 meg resistor sitting in here, so they really aren't doing the same thing. This one is the one that's rectifying the output of the IF, and it's coming down here, heading for the volume control, no doubt. Here's the takeoff. How's this work? Maybe it's one of those push in a long nosed. I don't know how that works. Okay, I don't know that there's a switch here. Oh, there's a switch on the back of the radio, right? The big words on it, radio phono. So this is a mechanical switch selecting phono, or the signal from the radio continues on its way to the amplifier. This is the volume control, as hard as it is to see. All this stuff on here, look at that. And then this must be the slider, capacitor, blocker off to the grid. This is the bleed for the grid back to the B minus. This is some backdoor arrangement for tone control of some sort, some tone compensation. It can be, you turn the radio down low. When you get there, the highs and the lows are actually boosted over the middle, something like that. I don't know. Something going on there. And so 470K. The other diode here, where is it going? So it's getting a feed through this huge resistor here. What is this doing? You know, I'm guessing it's the AVC. Yeah, I guess so. Straight off, straight onto, but not the grid, onto the suppressor. Down here. Okay, so this will get us up to the grid. Suppressor. Okay, we'll follow this along. Not going here. This will be the Avc capacitor between the AVC line and the B minus. So this is controlling the rate of the AVC voltage variation. Big resistor. Same thing again. Up to the suppressor grid. But really, the AVC is heading through here to vary the bias of this grid. What's going on here? I don't know. I've never seen that before. Usually you would connect the suppressor rate to B minus. Well, you know, when the engineers are designing these things, they're in a competitive environment with lots of other designers designing radios, and it could be that some kind of discovery was made by the guys who designed this radio or something, I don't know, and this is their secret little trick to improve something. Who knows? I don't know. But I don't think I've seen that before. And this guy in the middle. Now, so is there any other AVC on this? I don't think so. Yeah, I don't think so. Let's come back this way. Follow it this way. Doesn't look like it. No AVC affecting this tube. So basically we've got a tuned antenna, tuned with the capacitor, feeding the grid of the 12SKJ7. Output fed through this fancy transformer arrangement. Tuned arrangement. Out of here comes what should be a lovely signal going to the grid of the mixer. Lovely in the sense that it should be focused pretty tight on the signal of interest. I think. We're out of here. We're going to investigate this line. I'm going to put my SDR on this line at some point, and we're going to look at all the stuff that's on here. They've done this on the last couple radios. One of them I put on video for people to see. wild stuff. I'm not sure what to make of it, but I'm going to continue that line of experimenting as I work on radios. Try to understand more and more of what is coming out of the mixer tube. It's not enough for me to say all that stuff on the screen are products coming from the mixer tube. I believe they are when I do this kind of test. But I want to know exactly what it says, exactly what's going on. Why are they moving the way they're moving, all that stuff. So that's why I want to continue experimenting with that situation. And I had thought there'd be nothing here also. That the accidental products coming out of this tube were snuffed out by the impedance in this area here. But doesn't seem to be the case, at least on the last radio. And we could even be looking at what's coming on here, what's coming out of here. We can do lots of things with that SDR. 35L6 beam power tube. Cathode resistor. Is it bypassed? It appears to not be bypassed. Save on one capacitor. I put the 50L6 in here. I don't know, is that the right resistor for a 50L6? I don't know. Probably not. Okay, I think that's all we can extract out of the schematic now. I got a pretty good idea what's going on in this radio. There's nothing terribly surprising about it, except it's got the extra tuning section on the tuning capacitor in this front end tube. So this guy should really work well, but probably not with all those parts in there. So the next stage we could do, and I think I will for fun, is we're going to raise this guy up, raise up his B plus using a shop supply. I'm not going to plug it in, that's for sure. And we'll just see what happens. I mean, the radio's not going to operate. That's not what I'm trying to do. I'm just trying to see if it'll hold B plus in the high voltage circuits of the radio, or is there a short circuit, or is there a really, really leaky capacitor, or a whole bunch of them, or something like that. That's really what I'm up to. So we're going to do that with this guy here. With this I could put a controlled voltage onto the B plus circuits in the radio. So look at this capacitor. I see two connections here, and I see one at the back. I see a black wire. It's really a pretty safe assumption that in fact this is the ground side and this is the positive side. The reason there's a bit of assumption here, it's shorted against the side of the can. Actually, when he soldered it, he may have shorted it right against the side of the can here. We already know that's not the way this... Okay, let me back up a little bit here. Okay, so we have to decide where we're going to connect our power. So our high voltage power. Big capacitor is a great target. Stay up there. Now, unfortunately, off camera, I moved this wire a bit. It was right up tight against the can here, and it looked like whoever soldered it with it against the can, and it may have shorted right to the side of the can. And if that's the case, that's exactly the kind of thing that would make a radio like this super dangerous, because unintentionally, this connection against this can could result in the whole chassis being live right from the plug. Well, somebody else has done work in here. Not that I'm Mr. Perfect, but I have to be cautious about other people. And when I look at this does not look very good, frankly. So let's power this guy up and see what happens. Could be exciting. Now I can pick either one of these. Doesn't really matter. I'm picking this one here. There really shouldn't be any current flow in the radio when I do this from the power supply. It should just be putting electrical pressure on everything. No current flowing. But my concern is there is going to be current flowing. So the way this is handled with the power supply appears really simple. You just have a meter on it. This one here measures current flow, has a red line up there where the warning, don't go above the red line. That would be quite a bit. That's 100 milliamps at that point. And this is the voltage that is coming out on these wires. It's moderately accurate. So I'm going to flip this on from standby. And I want to keep an eye on this. Initially, I'm going to raise the voltage turning this control. This will go up. I want to watch this and see what happens. If it goes way up, bad, 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 bad. So what I can see it doing, and you probably can't, is every time I advance the voltage, the current meter goes up and then falls back. And that's perfect. That's a charge going into the capacitors. We're at about 100 volts. Okay, so maybe now you can see it jumping up. We're about 110. My video's flashing, eh? Well, that's just that's a video camera effect that you see some kind of flashing thing going on. It doesn't like the pattern on my sleeve, I think. Here we go, a little higher. How high do I want to go? So a radio like this has B plus around 140, but we should go a little above that. So now it's starting to draw. Well, no, it's falling back, falling back. 150 volts, it's fallen back to pretty much nothing. Now I don't know for sure that this radio is wired correctly. And I had the tubes out. They shouldn't really matter whether they're in or out during a test like this. What this tells me is there's no short circuit in the high voltage circuits of this radio. And you could potentially operate it, except there could be other problems that this is not identifying. So, do we dare turn this thing on? There's one capacitor which you can see it up here. I mean, it even looks like it looks like, I don't know, it looks like a furry bug, like a caterpillar or something. Now, before I get myself a shock here, let me turn that down. You can actually see the radio discharge. This meter goes backwards for a while. You can actually see the capacitor's discharge out of it. And only because I don't like the shocks. Nobody should like a shock. I'll take this out of here and I'll put in a shorting strap, so to speak. But I'm pretty sure that there's enough leaks in these capacitors that that stuff is just drained away pretty quick, I would think. Shall we operate this radio? Always fun to do that. I like working on radios that are working to any degree. Any degree. If they're working to no degree, I don't like that. So I think what I'm going to do, I'm going to load them up with his tubes, and I'm going to get the speaker connected again, and we're going to try this radio out. See what happens. I almost forgot I have to change the cord. I don't dare plug this radio in with the cord that it's got. The insulation is cracked right through the grommet hole there. There's no rubber grommet there. Something's gonna short somewhere in there, and there's that egregious capacitor. Yikes. So we do want to replace this guy here. Let's see, where's he going? I don't need this shorting strap on anymore. Probably didn't need it in the first place. So 2 terminals on the back of the on-off switch. Yeah, which actually appears to work. And it's the more difficult to get to terminal, of course. And the other wire, the other one, right down in there somewhere. So first let's get some stuff out of the way here. I don't want to lose the original connections yet. Oh, I don't know, did you hear that? Listen to this. We're going to find out what this wire's like going through the hole here. Just going to nip it off here. Let's see what it was like. Oh, it's probably okay, actually. But under that tape, hey, ooh, that's a scary thought. Shove that over there. So now I got the two tails here that I can keep track of. And this big piece of junk here I'm going to get out. So I think on this radio I will put on a, well, we'll see what I got. I may put on a polarized cord, and a little more attention has to be paid if you're going to put a polarized cord on one of these guys. It's dark down there. I'll see. Okay, great. Need a cord, solder it in, carry on. Let's poke through here. So these are all specialized cords with special ends on them. Special. Well, not this one. Hey, that's about right. That's a vintage cord. Lots of flexibility. I think maybe this is going to be the guy, because the rest of them I think are all got terminations on them. That's a classic little plug there. Yeah, I think so. So these are all, the interlock cords and all that kind of stuff. I happen to have this one in there. Lucky break. Great. Or, I'd have to go, cut a cord off my wife's hair blower or something like that. And that wouldn't be a good idea, let me tell you. What's underneath here? Go. So, this cord's been kind of coiled up a little tight. Not sure I'm the one who did it. Yeah, surprisingly good shape for a vintage wire. This is a non-polarized plug. So the safety of this radio is dependent upon two things. One, the connections between the chassis and those two things is done properly to the B+. The B+ not touching the chassis anywhere. So that has to be done correct, and the person who owns this radio knows. That's the tricky part. This thing has a phono plug on the back. I mean, it's inviting people to fool around with it. You're going to plug in the phono plug, you're probably going to touch the chassis while you're doing it. That's so. Let the buyer beware. Yeah, I won't keep this radio. This radio will be on its way at some point, someday. In fact, I have about a dozen radios that are leaving here today. On their way. On their way to their new life, wherever that may be. Pull this around here. Typically they put a knot in the cord to freeze it here. The knot then stretches all the rubber and plastic and sets it up for cracking. I don't like doing that. I'd much rather use either a classic kind of grommet in here. There is something in here. I think there is actually a plastic liner in there, but you couldn't call that really a grommet. Something in there. So I can put a tie wrap right on here, which would lock it from going out. I think that's what I'll probably do rather than tie it in a knot. It's actually much easier anyway. The knot thing is a bit of a difficulty. Okay, so we're going to make the connections now. There's copper in there. See more clearly where it's connected now.
mistakes with that. Terminals have large blobs of solder on them, which have sunk, sunk down from gravity. And so each of these terminals has a blob at the bottom, and those blobs are almost touching. There's very little clearance between these because of that. So something to watch out for. And then this guy, unfortunately, he of course is soldered to the lower terminal on the back of the plug here. That's not going to help. How are you going to get down there? You want to make a good connection, and one you can see, and one you know hasn't gone bad. There's one wire going to the power cord wire going to that terminal. The other switch terminal has 4 wires attached to it. I'm looking to see if that's absolutely true. I'm sure it is. Tricky to get in there with a soldering iron. I'll practice a bit here. It can be done. I can do it. I think it can be done. When I take this power cord wire, which of course is a big stranded wire like this, I try to get it in there. Down in there without having it spread everywhere. Wow, that's tough. That'd be tough. And again, I tin it up first for sure. It's still going to be tough. And while I'm staring at this, there's the back connection on this volume control, and on the schematic I thought we saw stuff connected to this. There's solder on it. There's some solder on it. Am I blind? There's nothing connected to it. That's kind of a curious thing, isn't it? And more to that, this appears to have nothing connected to it but that resistor. I gotta wonder if there's supposed to be a wire from there to here. Keep wondering. Wonder. Okay, well, I'm just going to struggle away and get that done. And we'll be firing up this radio and seeing what it does. Smoke and flames. Well, here's a close-up look at the back of the switch, and you can see the remnants of the stranded wire that was there going down to that lower terminal, which I really think I cannot solder to securely, not down in there. So what I've decided to try is I'm going to solder to the stranded wire, and then I'm going to try and cover it with shrink sleeve. That's kind of my objective here. So take the camera out of there. That's my objective. So I'm just going to slide some shrink sleeve up here. Try to solder this down low as I can, and then cover it with a shrink sleeve. I don't know what else to try. Let's try that. Holy smokes. I got it. Not sure what's left of the radio down there. There's solder everywhere now. that's it. And I'm going to get a close-up look at that. Let us take a close-up look at what has happened here. About like that. I've been fooled by my own eyeballs doing this kind of work quite a number of times. So I'm looking for a solder bridge. I'm worried there's a solder bridge in there. Right in here. Just pieces of debris. I'll just knock them further down in the radio. Actually, it goes through the hole here and fall out the bottom onto my bench. Okay, so that's soldered. And it's actually a resistor lead that they brought through here. Just what's that little? Ooh, that's a free strand. Get that guy out of there. Ooh, get him out. Get him out of there. Wow. Ooh, you certainly don't want something like that floating around inside your radio. Any more of those? That's the deal with stranded wire. It frays, the strands go where you can't see them, you get into trouble. And talking about trouble, so there's my shrink sleeve. That's perfect. That's great. And then just checking this one here is fine the way it is. I could cut that little nubbin off there. Maybe I will. Cut off the nubbin. What I do is I put my finger on top of this kind of stuff when I snip it. And then it's held by my finger. Okay. Looks a little scary, doesn't it? But that's okay. That's good. That's perfect, actually. Great. Okay, man, we're getting close to plugging this thing in. Yeah, that sounds exciting to me. It is again. I like this. I like to see, how these radios operate in their horrible original condition. Okay. Now, is there anything else we need to do before we turn this guy on? Now, I'm going to be turning it on with control. Okay, I mean, this isn't just plug it in the wall and let Niagara Falls pour through here. That's not what's going to happen. So we've seen, looks like some things missing off of this terminal. What does that matter? Probably doesn't matter much. You have this capacitor that looks like somebody chewed on it. I don't think any of that's going to matter. Flip this over. It's missing a few tubes now. Now the antenna wire popped off here, this one, and it goes on one of these terminals. Anybody tell me which one it came off of? So I had a little problem to deal with. And then we're going to stick with the 50L6, 50L6. 35Z5. I'm going to make sure these two tubes just went in the right sockets, because that would probably not be a good mistake to make. So what is in line with this? And I will look at the I'll just peek at the schematic here myself. What is in line? Wait a minute. Why did I think there was why did I think I had a diagram of that? Oh, I do. It's on the it's in the cabinet. Yeah. Okay. Cabinet. Just to make sure. I don't trust my memory anymore. So the 35L6, 50L6 is in line with the IF. So that's got it. I got it right. I got it right. So I'm going to do something about the speakers now. They're the speaker. I could hook up a temporary one here, and I think I'll do that. Right? Otherwise, I have to bring the cabinet back up on my bench. That's a little big. that. I just need a couple of things done here. Is that a tube rolling around? What is that? A couple of things done here. Some clip leads now. This is what I dropped on the floor earlier. Pretty rugged. Just going to check my clip leads. Good. Good. So speakers come with different resistances or impedances. This one is an 8 ohm speaker according to what it says, but it's 8 ohms at a certain frequency. I don't think it's 8 ohms DC necessarily. Let's get this out of here. Turn that off. Still haven't hooked up this. Let's not worry about it just now. Could be other concerns are coming. Bigger concerns than that. Okay, cord. Yeah, that's good. Surprising. In we go. Now we practice. On, off, tuning. Chances are I'm going to turn this thing on and it's just going to hum like a son of a gun. And that's going to be the end of it. So I'm going to turn it on. And I'm going to apply the power through some dim bulb, using a dim bulb system. If you don't know what I'm talking about, type it in Google. Dim bulb, I don't know, electronic bench or something like that. Dim bulb system would probably get you there. With only the small bulb in, we have the volume turned on, switch turned on rather, tubes are in place, speakers connected, antenna not quite. Just want to see what's going to happen. I'm wearing protective goggles. No, I'm not. Okay, as soon as I hit the switch, this guy's going to power up. And so the deal here is, if there's a serious problem in this radio, this light will come on really bright. And that'll save everything, save me, and give me a heck of a warning that there's something wrong. Typically what should happen is, flip on the switch, this light should come on a little bit, and go down, maybe to the point where it looks like it's off. And then as the tubes begin to conduct current, and more draw from the radio, you'll start seeing it in the filament again. This varies with every radio. It depends how many tubes are in it and stuff like that. Or if there's a short circuit. So is everybody ready? Because I'm ready. First test, so we'll turn it off. We're going to test the on-off switch. Essentially, you might as well look like this. Be testing yeah, back up. Don't be so close to this thing. With it off, to make sure off really is off. So what I see is full house voltage here, 124 volts. So I know this thing's drawing nothing. Okay, now we turn it on, but the power's off. Now, next click you hear will be turning on the power, and watch that light bulb. Glowing, ever so slightly. You probably didn't see it, but I saw it. That's a good sign. The radio's running with 100, it's hardly drawing anything. It's hardly drawing any current. I can see that this tube heating up, so all tubes are heating up because they're all in series. 119. I'd expect this to be a little bit lower. So there's 124 volts available from the power company at my house. 116 are making it to this radio. That's enough to operate it, that's for sure. I don't hear any crazy hum. That's a good sign. Let's hear it. I hear a little crackling. Okay, so there's a hum, but it's on the volume control. No antenna, remember, no antenna. Can't expect too much out of this. 120 volts on that thing. Didn't hear much. So if maybe it's only capable of producing that hum. That could be it. Oh. I said oh because I'm thinking oh it must be maybe there's so much dirt in the volume control that maybe the slider's coming off. I don't think so though, because the volume is varying. Well, what about making that antenna connection? What can I do about that? Now, let's see here. So I really expected this radio to be inoperable. There would just be too much hum coming out of it. So without looking, and I should look, without looking I'm going to guess. It's this middle terminal. This radio's really got nothing coming from the front end, does it? Anybody, somebody. Okay, so I'm going to touch the plates here. Nobody making any sound. Could easily have this antenna connected wrong, but I don't think we're going to hear much out of it. Well, we're going to try, because I don't think it's dangerous to keep it operating. Let's give it a signal here to shove into it. Shove it in there. So we want this down. Okay, we're about halfway tuned here. So we'll try that. We'll put this. I normally want to put this on B minus. I think for the sake of this testing, it doesn't need to be on B minus. I think we can do just fine if I just connect it here. Okay, and over here. Okay, I think that's basically the way the antenna is connected. And it's the same sort of deal. Now, can we get anything to come out of this radio? Let me turn it to a lower frequency here. So we could guess this is 600. Okay, let's give it a bit more. Let's give it the works. I think you could say there's absolutely nothing coming out of this radio. This is a little unusual for me. And so what we're going to do, we're going to go down to the IF frequency now, which is probably 455, and see if that goes through the radio. I'm pounding it into the antenna. It's not a hint. Okay, I think that's all we're going to learn. Off. Just making sure off is off. Off is off. Great. Now, for those of you who are new to my videos, this is plugged not directly into the wall. It's going through a transformer to isolate it from the power system. So just there's things I'm doing here to make this safe for me to do, which you might not be aware of if you're a new viewer. I'm not going to explain them in detail because chances are you're not a new viewer and you know what's going on in my shop. Maybe better than me. So what's the bottom line of all that? The bottom line is like a typical situation here. We got to get rid of the hum before we can hear anything else clearly. I didn't measure the B+. There must be some B+ in the radio or you wouldn't hear anything coming out of the speaker. Despite the fact it's loaded with a bunch of sick capacitors, or they look pretty sick, it's loping. Now some people would take a radio like this, plug it in the wall, hear that hum, declare it working, and then try to sell it to you. But this one, no, this one is a special one. As I said, somebody gave it to me for free because they just couldn't bear to throw it in the garbage, and somehow they found me. And it's a bit of a family hand-me-down or heirloom, I think. But and his intention was to do this kind of stuff to it, but you know, it's as he put it, it turned out to be over my head. Look, you need some experience with this to make this easy. If you're starting out in this kind of work, I got a big raft of equipment. You don't need all this stuff to get along with this kind of thing, but at times you do need all that stuff. So this is one of those times, I think. Let's look underneath again, and the last thing I'll do is make a little plan of action here with this radio. Plan of action. Let's tip it this way. Plan of action. So, plan of action. Normalize the filters in this radio. Get rid of this thing. What is this? This is another fairly big capacitor here. I can rotate the shell on it here. We'll see what it is. Oh, 100, it looks like 100 at 25 volts. 100, I don't know what this is. 100, oh, there it is right there. 100 microfarads. Yeah, it must be a 25 volter. To be 100 at this size, it must be a 25 volter hooked up to the output tube bypass capacitor. And this is a two-parter, but we don't know what it is. Well, we're going to find out. Am I unplugged here? I'm not unplugged and I'm not turned off. Shameful you. That's why I don't like to use the switch on the unit I'm testing. I like to just be dependent upon my bench switches all the time, so I don't make that foolish mistake. I almost made a foolish mistake. Pull this out. My hand firmly on the chassis here too. Come on, out of there. What are you? July 65. That's how old this thing is. 150 working volts. 40-40. So it's a 40-40. Red outer. Red outer. Outer. So one of the tops here is marked red. And I can get this out of here. This is not gonna. No reason to leave it. I'm not going to gamble that this thing's any good. 1965. Red outer. So maybe that means the way this is constructed, the capacitors are sort of one inside and one kind of outside, and they're telling you which one's the outer. Never seen that on this kind of capacitor before. Made in England. Plessy, UK. That's why it looks so odd to me. I've never seen one. Well, I have seen capacitors that look like this, but not usually in this kind of position. Is there a chance that's original? No. No, it can't be. No, you wouldn't have this kind of thing happening or this. No, this is a replacement for sure. Well, more replacements. In fact, the kind of capacitors that I have to install on the radio, I've run really low on. The ideal ones, I've ordered 100 more of them. That's what I think is in my future. 100. Well, 100 will let you do 40 or 50 of these kind of radios. The 160 volt filter capacitors coming. Okay. So the deal here is replace this guy, and then won't do anything else, and we'll run the set again. And I don't know how long the video is at this point. This might be the end of it. If this is the end of the video at this point, then thank you so much for watching, and catch up with me tomorrow as I carry on with this. Or maybe I'll carry on right now. I just don't know. Okay, I've got the capacitors in there. I'm just going to shrink that shrink sleeve a little bit here. So I decided not to replace the existing wires back up to their terminals because it's just too hairy. And the fact is, the more you do with these radios, the bigger chance there is you're going to end up somewhere you never thought you'd be, with a situation you don't know if you can even fix it. Because stuff happens with these radios that you don't anticipate. Sometimes the best thing to do is just kind of do the minimum. Okay. So now this is just hanging free, but I'll figure out some way to stabilize it in that. But I did put shrink sleeve up over top of the old wire up and back there to try to improve it. Oh, I meant to shrink this. Get them on the next one. So I still have this one to replace. You know what? This won't cause a hum. This one won't cause a hum. It's time to test. It is time to test this radio again. Okay, so antenna's taking quite a beating back there. Now, sometimes when you fix the hum problem, not much holding that on. Sometimes when you fix the hum problem, a radio actually comes to life afterwards. The hum, I guess, is just overwhelming the radio, probably in a number of different ways. We're going to find out if that's the case here. How we set. Plug in. I get rid of the whole plug before I plug. I might plug this in once. I'll get rid of this. Okay, is everything safe and ready? It is. Volume. Okay, so the switch is on. Watching those dim bulbs. Here we go. This is a big deal now. I did a big change. If I made a boo-boo, kapowie. Okay, perfect. You have the perfect kind of bulb action there. You probably couldn't even see it. That's good. Volume is low. Let's turn it up a bit. Wash your fingers. No antenna connected here. Or the antenna half connected. This is normally a loop antenna with resonance. Right now it's a bunch of wire coiled up with no resonance. Here it comes. Still humming. Well, let's see if we can get anything out of it. Well, that's a volume control. Jim, I'm not going to get anything tuned out of it with that. We need to bring on a strong antenna, which I happen to have handy here. So we will power it up. Regardless, this won't matter then, regardless of the loop antenna, this has got enough juice in it. So we'll go on the chassis. I may have to run and turn this antenna on. It may not be on down here. I'm going to just go first on the antenna. Do you hear anything? Oh, I don't hear a thing. Oh yeah, a little clicky sound. Not much. This radio's not working very good yet. Place to clip this on and around. Oh, right here. And now I'm gonna have to. I don't think there's much coming through. Yeah, I don't think it's worth trying to experiment more with it. That's where it's at now. Dead. Dead. So, a couple of approaches I can take. I usually work from the audio end of the radio forward to the antenna. This radio, the audio side, seems to be working because we can hear a hum coming out of the speaker. That's not really a guarantee though. And we know the tubes have no shorts in them, so you couldn't get a grit cathode to heater short making that hum. That's not where that's coming from. It really does sound like power supply hum, doesn't it? Still. But it could be all kinds of things. There could be open capacitors in here. There could be all kinds of things that are causing this terribly unstable radio here. Let's put it that way. Okay, next thing would be, I think probably, well, I'm going to get rid of this one. I may not. I'll let me fool around with the audio circuits in here a little bit and see if we can just sort out what might be happening a little more before changing everything. I think we can be pretty sure all those capacitors are going to go in the long run. But that's good for now. Well, it's not terribly good, is it? But that's okay for this video. Next video, we'll just keep trying to drum out that hum out of it until it starts sounding like a radio. Thanks for watching.